happy that there are things like the unbreakable pipeline on the agenda, that we are thinking about the quality software team helped organize this event, because the monitoring and the testing is essential in that. And we need to make sure that we build pipelines that we automate in a auditable fashion and in a controlled fashion, because our clients, our customers, but also our employees are counting on the fact that it is in control. And it is my firm belief that software controls are a lot better than process controls. I'll give you an example. Right. We have SOX tests. And SOX make sure that our annual accounts are true as they are published. And that comes from Enron and WorldCom. And they were thinking about going back and back and back and back. Who can change something in the annual accounts? And then they came up with, okay, actually, an ops engineer and a software engineer can change the annual accounts. Have I ever encountered any company that even came close to the situation where a software department was changing the annual accounts of a company? No. But hey, it's a control. But it's not about the control, it's about the framework that you think about. I want to be in control. I want to be sure that my software cannot be tampered with. And in the last design effectiveness control, we found that our pipelines are not always waterproof. And that's a shame, because then we have to do all kinds of manual and process tests that are, in my view, qualitatively much less than our software controls. And people are spending hours and hours and hours and hours just to make sure that during a half year and during a full year, we publish the right numbers. And I believe that if we work together and if we learn from each other, if we train each other on what are the coding rules that we use as a group, and how do we form our pipelines, that we actually are going to be faster because we learn from each other, and we're going to be more in control because we'll have software controls instead of process controls. And that's therefore a tension that I sometimes feel in the organization that I think is not there or shouldn't be there. We can be twice as fast and twice as much in control. Now, going back to what you're going to talk about here today, you're going to talk about twice as fast. You're going to talk about automation. And it is a topic that is close to my heart, dear to my heart. I'm very happy with the movement that we're making, with the tempo that we're making. And I want you to keep pushing on, because the company, Rabobank, really needs the speed. It is my belief that it is not our strategy that in the end defines whether we are a winning bank, but it's our pace, it's our speed, it's our velocity. And you are instrumental in that. Thank you very much.
Thank you, Anton, for opening the automation event. The agenda, why you came here. First, of course, we have Paul de Rij from Coolblue, who will be telling us about their journey and the future of the automation at Coolblue. After which, we have all kinds of breakouts. The first one here is about savings at ZOS, Innovations, Insights in Innovation by Dennis Mess. And the new part of our event is that we now have 2 clinics in which you can get your hands dirty and work together with us building stuff. It's nice. It's an experiment like everything should be. Yeah. Tell us afterwards, if you joined it, tell us afterwards how you liked it and if we should be doing more of those, because, well, I'm kind of curious how you feel about it. At the end, we get Jeff Beeler. He's not here yet. He will be in due time. From Microsoft, who will tell us all about the VSTS journey. And, Azure DevOps journey, which is the new name of the tool, and how within Microsoft they came to VSCS and all the what their learnings were. So I'm hoping you're just as curious about his story as I am. There's one break. Yeah, there's one break, sorry. During the break, we have, of course, something to eat and drinks. During the event, you can just walk by coffee machines and tea machines and whatever. You can get it, it's for free. And otherwise, I'll pay for it. And just enjoy, yeah? Paul, please.
So, hello everybody. Everyone can hear me? Cool. So my name is Paul. I'm a technology lead at Coolblue. That sounds very interesting, but it's just a very technical name for jack of all trades. And today I'm going to tell a few things about automation on how we do things at Coolblue. It's mainly my personal view and the things that I've learned over the years. And from what I understand from the introduction and the schedule is that you guys are going to talk a lot about automating infrastructure today. In this session, I'm going to take it a bit further. I'm going to think about what we can automate for our clients, our customers, the people that we build our software for. And it's just some things to think about, and maybe you'll learn one thing or two, and then I'm happy as well. And cool, we have background noise. We are in such interesting times. We are on the verge, or we are already in the era of the fourth industrial revolution. It started way back with mechanization and steam and power. Then we got into times of Ford, which gave us mass production together with a lot of help of electricity again. And that was already major leaps if you look at the time, at the history and the time. And we come out the world of Industry 3.0, or the third industrial revolution, which brought us a lot of automation, robots. And that was cool already, right? That brought us a lot of new things, a lot of innovations. But you still had to program those robots. You need to tell them you need to move to that coordinate to start a weld there or things like that. And we're hitting that new era. We're hitting Industry 4.0, which brings us, for example, autonomous machines. You're just saying, hey, here is my design of a new car or state, and he will figure out what the right coordinates are to do operation A, B, or C. It's very powerful what will happen in the future. It brings us a lot of autonomy in machines, and Hollywood tells us that this will be next, right? We need to fight robots because they got too smart for us. Maybe that's the truth, maybe it isn't. One thing that I also see in this Industry 4.0 is that everything is smart. If I look at our product catalog, it already shows, right? We have smartphones, we have smart watches, your refrigerator is smart, the washing machine is that smart. We put sensors in everything, almost everything. And the fun thing about it is that it's not just, is my door open or closed, or what's the temperature of my refrigerator? We do a lot of cognitive sensors as well. Think about your fingerprint or other biometrics. And just to show you an example, this was 2016, a presentation of Jack Ma.
At the second year of the handover, it's a souvenir step selling online for 20 euros. So we're going to buy it now. And how do you buy it? We just press buy, and it's the face recognition. It works. So in 6 days, we are going to confirm.
So this was in a conference in 2016 in Germany where he presented this. 2016, we're now 2018, and we're nearly not here. The technology is there, but apparently in our mindsets, we have somewhere we don't accept that we can pay with a selfie. No, we're still in the era that, if I look at our Slack channel, I often see, hey, who has a random reader, or who has this or that, because I need to make a transaction, right? You can do it with your face, but apparently we're not there yet. Another thing that I see in this Industry 4.0 is that a lot of it is about connectivity. Yeah, we had a chat before, and one of the things that I noticed is that there will be a lot of big companies that give us the building blocks. Think about Google DeepMind. Think about all those services that AWS offers. And where does it leave the most of us developers? I think it's about connecting all those building blocks together, moving data from A to B to C to D, and providing a real good interface to our customers so that they can do their business or so that they can buy. If you look at the trends that are going on, is that there's a lot of focus on APIs. There are many people and companies that are now pushing for an API-led architecture. A lot of this in this Industry 4.0 is about the data. You know, all those saying about the data is the new gold, it literally is. It will be most of our job to get that from A to B. And that requires us to think differently. If we hold on to the paradigms that we had in the 90s or in the 80s or even in the zeros, we will get behind. I think it's as simple as that. So, you know, we need to start putting a different thinking hat on. You don't just have to believe my word for it, because I have my own interpretation, but this guy on the left is Igor Böger. Maybe you know him as he was a professional soccer player back in the days. And now he shares his vision on technology and the things that he sees happening. And I think there's one great talk of this guy, which is the madman versus the madman. And on the top, you will find the big brands, the Unilevers, which we're all mad about because of the taxes. They really believe in advertising. Customers don't know what they want. We'll tell them what they want. We'll just make great advertising campaigns, right? And that's still the paradigm that they have. But, you know, they got turned around by the guys below. They just collect a lot of data. They learn what we want as customers and start building products for them. This talk, you can find a quite old version of him online, but if you can ever see him, go watch this. This really helps you to put the new world in perspective. And what it did for me was to reconfirm is that mindset is our bigger challenge than technology. We can build with technology what we want. I'm quite sure that if you just put enough time, put enough effort at learning things, you will learn. The hardest part is taking along our customers or maybe ourselves. You know, we need to get out of that comfort zone. We need to look into new areas to build that thing. And I will show some examples of the things that I've seen at Coolblue in the last 12 years. But first, I want to look at, actually where most of you are now working off, or what the current time things that you're building with, and that's the world of automating deployments and provisioning. Because I was almost 5 years ago I joined Coolblue, and of course we need to deploy software. And maybe people know this. Ever did a MAN SCP? That was what I had to do when I did my first deployment at Coolblue. I was literally looking like this because they told me, yeah, you have to log into a server, then fetch the latest change from Git, hope you're the only one, and then do this script that will do an rsync or an SCP underneath, and then your new software will go live. And there's no way to check if it went well or not, or if you're the only one doing a deploy. You just have to guess, or maybe just do a walk around. I was scared as hell. Of course, they had me done it at the end of the day and all that stuff. And luckily, a lot of things changed, right? We introduced our own continuous delivery and deployment pipeline. We've chosen TeamCity for various reasons. But now at least I didn't have to log in on a machine, get latest changes. We've automated all those things, and we've put a lot of sanity checks in there to make sure things were up to standard and that we could fail fast. So you could see that in the top where we do some of the buildings elements. That's also where we do a lot of checks, because we want to know as quickly as possible if we failed, if things will not succeed. Because the life cycle, that cycle needs to be as small as possible. We've automated our smoke test. So I think it's here. The acceptance integration test step, that's where we do a lot of automated smoke tests. We deploy our software to acceptance, and then we just do a very simple HTTP request. And if that's not a 201 or another different status code that we expect, we just stop deployment. That would make my life way easier 4.5 years ago, because that gives a lot of trust to say, hey, at least I'm not breaking a production website, and it tells me what's going wrong. We've added a lot of statistics, monitoring, observability. If you go live, then I can see what the impact is on my infrastructure, but also on the usage of the application. We just simply do not monitor, the CPU or the memory or hard disk or things like that. We also look at how many logins are there, how many people are now effective in the checkout or in the, are paying. And that's really important because it builds a lot of trust for us as well. And again, it brings us to a very good feedback loop. You all saw the Rickroll, right? Cool. And even we have a lot of projects that we can do automated revert because we have those statistics. We can just look back in history if this, is this normal behavior or not? If not, then just revert. Go back to the latest version and then let us know, and that will make sure that we fix it. Good to know we don't do this with all of our projects because for many things we believe in fail forward as well. Just tell me as quick as possible, and we make sure that we get a fix in minutes instead of doing a lot of sanity checks to make sure that everything is picture perfect. In the end, we are an e-commerce company. We're not sending people on rockets or things like that. We have a different risk profile than NASA, or maybe for you guys if you're in a very transactional system. So we can accept that risk. And this was not just for the technical people, right? This was also very important for our business because we made deployment way easier and we gave way more insights about the effects of deployment. We got into a reliable feedback loop. Nowadays, we do around 100 deployments a day. If you go to our website and you go back an hour later, something has changed. Most often, you will not really see it because it might be in a part where you're not active. But this gives a lot of data so that we can really adapt and inspect. We just put something live, we learn from it, and the next day we can decide if we want to continue that road or if we want to do something differently. That's not just powerful for us as developers, but also for our business. They can make so many more choices and experiments. That's really awesome. So selling automation to your stakeholders in the business, this is often why you do it. It's for reliability. Yes, it is for stability, but you give a lot of the opportunity for them as well. A lot of learnings, a lot of insights. At least that's the best easy sell I did in Coolblue. Other thing, once in a while you need to buy new hardware, or nowadays hopefully you might be running in the cloud, or maybe you have your own data center. But also, I think 4 years ago, we needed to add 4 servers to our web area, and that was 4 servers. It doesn't sound interesting, but for then it meant I think 150% additional capacity. This is roughly how the process was. Someone went to the data center, hooked up the new machines, and then someone went looking for the configuration and then hoping it was updated and then doing all the steps manually. I think after 2.5, 3 days, things were up and running. That's luckily not the area we're in right now. We've introduced configuration management a long time ago, which was really powerful because then configurations are actually documented and being kept up to date. It also meant that we could take away a lot of server access for a lot of people because there was no reason for them anymore to be on that server. And I think a year later than that moment, we added another 4 web servers, and before the guys were back at the office, they were running in production. So we went from 3.5 days with a lot of frustration for the people that had to administer to something that went as smooth as arrived from Amsterdam to Rotterdam. And it didn't end there, right? Because we're now in the world of, well, public clouds or private clouds that offer a lot of configuration already. You know, they take care for a lot of things with their managed services. And by using infrastructure as a code, you know, we can do so many things, not just on the very detailed configuration, but also by the abstractions that, for example, CloudFormation gives us within AWS. It's so easy to write new configurations. Even we're now in the phase that, you know, spinning up a new DTAP environment, we can do it in minutes. It might take me more time to get this cup of coffee with instant coffee than spinning up a new DTAP environment, including the build pipeline in our team city. The world has changed. And again, like I said, I believe that we're going to use a lot of building blocks offered by big companies or very niche companies. This is, for me, the biggest example. If I look at what AWS offers in their whole portfolio, we're just using what they built for us. We hook it up together. We make sure it's a seamless orchestration. And that's where our job is done. And we can take a lot of the benefits that AWS give us. So that's a lot about, you know, automation, about the infrastructure. Let's also talk about what we build for our customers. And customers could be external or internal, depends a bit on what team or what area you might work in. Because I'm quite opinionated about this. I don't believe that any stakeholder comes to you and say, hey, put me out of my job. I have a problem. And part of the solution is that you know, just make sure I don't have a job anymore. Especially if you talk with people that are very passionate about what they're doing. They really believe that they are making the difference, but there's automation or there's, you know, things that we can do as software developers to make their lives easier. And that means that if you talk about solutions, those solutions will actually have boundaries. And the boundary is, you know, I need to be involved in that. I need to do an action. I need to be part of the process. And I've learned this in a project that we did. You might have heard that we migrated 360 shops to Coolblue as a shop, to one domain. Has a lot of business benefits, has a lot of SEO benefits, and for us, it meant the start of a new technical platform. And I'm going to take you to this very quickly. So here's a screenshot of such a shop, pdashop.nl. And what you see is that there are all kinds of entrances to what we call facet pages. It are selections of the assortment that we have. And just to give you an example, if I would go to pdashop.nl/Apple, someone had defined in our system that the facet Apple mobile phones consist out of the product type smartphones, the brand Apple, and he added some information about, you know, how to order it, how to show it to the customer. Sounds not that hard, but if you think about that, we had at least 100,000 different entrances that were all manually managed, and a facet like Apple smartphone is quite static. But what about gaming laptops? The specification of a gaming laptop changes every 3 months. Now, in the beginning of the year, it's an i5. Then we need to move to an i7 with an NVIDIA 503, I don't know, number. So there's a lot of manually work in this. And then also to think about all those filter options that were on the left, you also have to manage that. You also need to make preferences there. I think we had roughly 30 to 40 persons that were working on this constantly to find the best configuration of those pages to make the best conversion. And then I'm not even talking about the technical difficulties that we have with this system. There were many. And along come Elasticsearch along the way. And Elasticsearch is a great product, you know, offers a lot of things. And for this case, what it also offered us was that if you go to the found documents or the document set, it could give us the right aggregations. So I could say to Elasticsearch, in the documents of, in this case, vacuum cleaners, there are a few properties that I want you to aggregate on. For example, give me all the vacuum cleaners that are suited for a wooden floor. And there's little configuration for this needed. I can just give a very generic query to Elasticsearch, and he will give me the different facets, different aggregations, to keep it in Elasticsearch terms. And when we had that, we could also say, hey, but that means that we can, those filters, we can automatically display it. And we could put a little bit of intelligence behind it to find the best format or the best way to bucket these things. That was quite awesome that we could do that. Because we saw, hey, that means a lot less manual work. Almost none. So we went out, we showed it, and the various stages, and all those people were, what? What have you done? You know, I need to do this. There's no way that a computer can do this for me because I know all the stuff. I know what needs to happen. I know what the customer wants. True, but that's not the future. It is different, you know. There are so many things that we could learn out of the behavior from a website to make choices or to give that to an algorithm. And that's where it made sense to me that, you know, we can build a lot of things, but if you don't take the people along, it will be a very hard fight to get this done. And don't get me wrong, right? People that are not doing this work, it's very easy to get this understanding, right? Hey, look, you don't have to do that anymore. That's very cumbersome. You can work at different things that are way more impactful at the company. But if you're passionate about this, then it makes it very hard to understand, hey, I'm replaced by a machine. And along the way, with a lot of talks and a lot of understanding from each other, we got it done, right? Coolblue.nl is working. It's mainly automated, quite cool. But what still out for me is that we have to accept as humans that we're not going to do the bulk work anymore. There will be a time that no one steps into an office for 8 hours to fill in data or to make choices. We're just asked by the computer to look at the exceptions where the algorithm doesn't feel comfortable enough, or we say to the algorithm, this is not up for you to decide. And this is not just in the software that we build, but we'll see it in cars again as well. I thought, hey, let's take a cars example. This is the same paradigm as what we're putting in these cars, right? You know, you drive, but if you don't trust it, you have the opportunity to intervene. And of course, we all know that there will be a time that even that opportunity won't be there anymore because people tend to be unreliable. I never said that, of course. So again, you know, thinking about this, and let me show you a different project as well, where we've kind of hit into the same things. I think our product catalog is around 40 to 50,000 products. We're active in the Netherlands and in Belgium, so we need to price most products twice. So every day or every week, 100,000 products are being reviewed for their price. And of course, that happened in a system that we built. Coolblue exists 18 years ago, so let's say roughly 12 years ago. In a very different mindset, we've all been building, well, server-client applications. The interface wasn't the best thing, and if you're, if you're a buyer from smartphones, and I don't know, we might have 4,000 different smartphone cases. You need to price them all. It's quite cumbersome. It's quite, it's not the best day not the best thing to start your day. So we decided to intervene here. We wanted to build a new application. Our current ERP system is called Vanessa. Fun story about that. If I have time, I might tell it. So we built a new one, Vanessa Dupree. And we said we need to build this in a new application. And we decided that, first of all, we wanted from a CRUD-oriented style to a task-oriented style. And what do I mean with that is that, you know, we just say, this is the product, this is the price, you won't need to fill it in, and we'll move you to all those products instead of showing you a big spreadsheet-like screen, which is very error-prone, and it's not very motivating as well to see, I need to go to that whole list, then get another cup of coffee. And as you will see in my next slides, there's more power to this. So that's where we started. We just started to build an application. Unfortunately, I can't show you the real screenshots. It's simply too much information. I would need to blur out almost the entire screen apart the icon I show you at the beginning. So I did my own best at design skills. Yes, this is the best I can do, sorry. But just to give you an idea about what we've done. So the first thing we did is that, well, of course, we took a very small segment. So I show you smartphones, but I think we started at some accessories for smartphones like USB cables or smartphone cases. So we took a very small thing and we said, well, let's simply start building an application where you can see the product that we feel needs to be priced, and then ask for a price. And if people don't want to do it, they can postpone it, or otherwise they just enter the price and we'll make sure it's updated in the system. So this is also the stage where you do a lot of the infrastructure, making sure that you have all those systems connected. And when people were happy with that, we decided to go to the next step. Because if you price a product, there's quite some information, so things you need to know about competitors or stock. You know, if you only have 2 left, you might want to up your price a bit, but if you have 200 on the shelves, then maybe you want to lower your price a bit because we don't like stock that much. But maybe there's a forecast, you know, maybe we expect to sell, it's like this summer. It's going to be a very hot summer, so maybe buy a bit more fans and maybe up the price already because it will be a very hot summer. So it's all things that you have to think about if you are responsible for pricing. So we started to show that information, that someone that was actually pricing could make that decision. That was cool. There was someone that was doing that and you know, making the choices very happy. And then we made the program a bit more smart. And then we took our own learnings that we've collected from a lot of data points and things that we saw that were happening. And then we say, well, let's let the program make suggestions to the price. So, you know, the application, the pre could say to you, well, maybe you should take 20 euros of this iPhone because we think it's smarter for the goals that we have with this product. And that was scary for people. They were really like, okay, A, how can a computer do this for me? And B, why? I was good at this, right? Yeah, of course. But there's a point in time that there are so many data points, so many things to think about for such a large set of products that, you know, it's better if we can help you. It makes your life way easier. And you can relate on how we got to this suggestion, but because we gave you all the information on how we make the decision. So if that was scary, then this next step was more scarier. Because basically, we just said, well, from the 28 products, we already priced 27 for you because, Mom, you know, you were so happy with the suggestions we gave you. I think you've trusted us enough. So we've done that for you. And there's just one thing you need to make a decision on. Again, this iPhone, if you really want to take 20 prices off. So that was, and important about this is that we took, of course, not maybe for 27 products, but we took an hour, we've regained an hour for the person that did pricing for its segment just by doing a lot of automated with even better results. So if you go and look back in the numbers and then look at, okay, you know, how was these products performing, the results were better because they were smarter priced. And this all sounds easy, of course. You know, I can make this up. I think it took us 2.5 years to get this right. We started a fresh three or four times because we needed to learn every time. And just to give you my biggest learnings is that these tasks, they proved crucial because by making it very isolated, it helped the person that actually priced the products in the UI. It made it very clean and it gave a lot of right context. But for us, it was also a very easy start to, you know, make this automated, to just, instead of showing the task at hand, pricing product X, we could put it into something that just automatically priced it without overhauling the whole application. It enabled us to go in parallelization. So actually, 1 year ago, we needed a whole day to price our whole assortment. Now we can do it in 5 minutes. And by moving from CRUD to task, that really helped us. Another thing that we learned, because I've showed it very linearly, but adding that information was actually after showing suggestions. Because we already did suggestion, because that was the goal of the program, right? Someone asked us to, you know, make a program that can show that suggestions. But people didn't trust the program. They didn't understand why those offerings were made. So you need to, you know, gain trust, not only in the program or in the algorithm that you write, but also just, you know, you as a developer that's driving this. people, the stakeholders, need to start trusting you and that you know what you're talking about. And what for us was very valuable was that we showed all those extra information. There was a shortcut that you could see, okay, this is how the algorithm came to this price, to this discussion, to this decision. So, building trust is very important. Also very important is that you take small steps. You won't change the world in the whole day and Rome and all those nice things, but they are true. You need to make very small steps, and it could be in the range of products in our case that you choose for, or the steps that you take. I think literally in the last 1.5 years of the project, we just took very small steps, very small, by adding way more information and then slowly building up, actually offering suggestions. And it was necessary. It was necessary for us to learn about the program and to adapt where necessary, but also to give the customers or the people that price, to give them some time to get used to the ID, to get used to the fact that they won't be doing this, that they have an hour to do talking with vendors, which is way more important and which is way harder to get automated than what they're doing here. It takes time for people to accept this. And of course, a lot of things are done in small steps. So, I don't know, people familiar with Google DeepMind and the competition in Go? Maybe seen the documentary AlphaGo on Netflix? Cool documentary. And also here is what you see is that they take small steps. They first took the European Championship player in Go, and then they found out, hey, the algorithm beats that guy. Apparently, we're doing a very good job. And then they took on this guy, Lee Sedol, which was the world champion, and they completely smashed him. If you look at the documentary, he's there for, I think, an evening. It's just, what happened here? And the fun thing about DeepMind is that I think 10, 12 years ago, you had the IBM machine that played against Kaspersky. That was built for that match. That was built to play chess very good. DeepMind is an algorithm that's built to learn from experiences. And that's a whole different ballgame. It's just not built to play Go, it's also built to do this.
So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
This is just mind-blowing and great for me, by the way. I go to the hair salon 2 weeks earlier if this is live. But it's just amazing to see that, the things that apparently a very generic learning machine algorithm can help you with. And, I said in the beginning already, I believe that most of our job will become to integrate with different APIs and send data from ATB. This is for me exactly the reason why. I will never be able, with all the money I have at Coolblue, or to build this with a group of people. There's no way to make that very economically feasible. I'm quite sure that if the CEO, Peter, comes to me, he says, I want this. I want to say that people come, talk to their iPhone or whatever phone and say, well, Siri, I just want to buy a new phone find me one and give it tomorrow, or find me 3 options. That's what I meant, we'll be integrators of all these things, because building this will be a very long time. So to wrap up, for me, I'll be happy if you take these 3 things as a takeaway. I really feel we need to think differently. The mindset, the paradigm from the 80s, 90s, the zeros, it's not valid anymore. We're entering new day and age. And I believe it's time to either go with the flow, or you will, as a company, I would say, then you're out. Small steps is very important. If you take too big of steps, then it's either your program is failing, or your algorithm, or it's just the buy-in from the consumers that you have. And more importantly, you need time to gain trust. You need to build that trust, that people can understand what the machine is doing, what the algorithm is doing, so that you can so people can blindly trust it. And I also think if for the automation, for the continuous delivery and deployment, people also need to start building that trust that, hey, if we also do it automatically, it might be even better than someone that does it maybe in your case most of the night, somewhere in the weekend or whatever. You can automate a lot of validations, conditions, or reverts, or all those things. So yeah, that's for me to close off. Any questions? Someone needs to be first, and often it comes. Yeah.
I got a question. How did you secure your pricing software? Because if someone hacks it or something, all your prices could go down, or how is that even possible?
Yeah, so I think there are 2 things. That's just making sure that we can display the prices, and of course we have the pricing algorithm. That's secure by being in many layers. It's not really connected to the big open world. It's also in private clouds. And a few other tricks I probably shouldn't talk about. So that. More questions? Someone not agreeing with me, I always love that. You don't have to do it publicly. You can just find me later on, no problem.
I have one. Yeah, I have one. 3 actually, but only if the others don't have one. You said take it gradually so people can start to adapt to it. Can you speed this up? Do you have any experience by speeding up adaptation?
I think it differs a bit for where the distrust of where the discomfort is. So if it's with developers, it's often just showing a lot about what's happening in the world. I always notice that developers really want to be top-notch and be up to speed with all the things that are happening around them in other technologies, of course. So just showing examples from other companies, for example, really helps there. If it's from the business side, it's mainly showing, experimenting, do all the proof of concepts that you can, so that they can experience. And the hardest thing about most of our job, or if you're like me on the verge of the technology and the business, is translating it well, playing the right lingo so that they can understand. It's the same thing with technical debt. That's always an issue to say, yeah, we need to solve this. It's technical debt, right? If you can find a way to address this well to your stakeholders, your business stakeholders, what the benefit of solving that technical debt is for them, then it's fine. It's just making sure that people understand each other well. So yeah.
We used to have a throw box, but yeah, not at the moment.
Hi. I was wondering, what if the suggestion is according to the person not correct and he uses a different number? He has a reason for that.
Yeah.
Do you use that reason to even make it smarter? Or?
Yeah. So if people are not applying or not following the suggestion but doing something differently, then they log it and we look at the log reasons. Why not? And often for us, it's because we're not in we have strategies for all kinds of product types, and the ability to register what our strategy is in a very deterministic way is missing. So that's why people are there for certain product types to override the suggestions. And it could be maybe we have an ambition to become market leader in a product type. Yeah, then you price differently than you might want to do if you look at the data points in the history that you have learned. So that could be one of the reasons that we often find.
Okay, but that's done manually still.
Yeah, in that case it is. Yeah, and of course, again, we're looking at new ways to do that. So I think, if you go from let's say roughly 60 to 70% today, our ambition is to get to 95 at least. But yeah, that could be 2 or 3 years in the making, because we now get into the exceptions that are quite harder to solve, and that's fine, right? We learn along the way. But for sometimes, the business speeds up or takes different choices. So maybe crazy example, but let's say trampolines. Trampolines might be, for different kind of reasons, a very hard product for us to price, to do that via an algorithm. And in 2 years' time, if we might be able to solve it, then we don't sell trampolines anymore. That's often how that goes. So yeah, you need to weigh priorities every time.
Will you ever reach 100%?
It's our ambition. But yeah, big foundation, hairy goals. I think it's also the balance, right? So how much money do you invest in this to reach that last percent? If you give very good suggestions and people are quite good at what they're doing there, yeah, maybe the cost of them doing that half hour in the week doesn't weigh the investment we have to do to build the last 5%. So it's always a decision that we have to make.
Okay, thanks.
So yeah, cool.
Other questions? DeepMind is one of the reasons that Elon Musk says IT is the most dangerous species to humankind, because in the end it can learn how to destroy us. How do you think about it?
So I stayed away from the topic of ethics deliberately, but
you're welcome.
I don't know, right? It's second guessing, right? You can stay here, you can stand here very firmly. Yeah, computers will destroy us. We need to go to Mars. Or you could say, we'll be fine. Yeah, there are things scary, but I think there will be a lot of things fixed in the end as well. I don't know. I think if we are too cautious already, then we'll never get into the advancements that we like us to be. So rather be a bit dumb and then see how it goes. Very personal opinion about this, right? Don't talk about this to Peter. He might think differently. This is my take on it. Yeah.
Yeah, many weapons started with good intentions, inventions with good intentions behind it. Yeah. Any other questions? Yeah.
You mentioned that you were using TeamCity.
Yeah.
I was wondering what were you using before? Because
well, before that, it was a CentOS box with SCP. I think 4.5 years ago, roughly about that, we made the decision for TeamCity, because at that time it was one of the few products that were good in as well the .NET space as the Unix space with PHP and Ruby. So for us, it was a very easy way to get a uniform way of going. Looking at the ecosystem right now, I don't know if we would have made the same decision. But yeah, 4.5 years ago, which seems like decades, that was the best decision for us. Yeah.
Yeah, well, the price mechanism will be self-learning in the future. Now you make an algorithm, and then you wait, but you have a lot of feedback. People can learn from it.
Yeah, I think that's definitely an option. It depends a bit on where we are in the market, and if there are very disruptive competitors. So I think for a few market segments we are market leader, and then that's a bit more easier, I think, to go for. But if you want to become a market leader, you take different choices, and not quite sure if the length of the period, the data set, will be large enough to make a very successful algorithm for it. Or maybe it's just you need to put too much effort in for it. Yeah, that. Thank you. All depends.
Other questions? No? I would like to thank you a lot.
Cool.
Yeah, very inspiring.
Yeah, I'll be around with the breaks, but I have to hit home early. But if you still have questions, then find me on LinkedIn and shoot me a message, and happy to answer that. Or just find me walking around here. Thank you all.
Yeah. And should you forget his name, contact details, whatever. Chris or any other of the development automation team can help you to you. Yeah, thank you. So we go on with the program. This is the moment that we saw with the first breakout sessions. There's 2 clinics. The Maven Jenkins 2 VSTS build migration pressure cooker. If you would like to go there, follow Adrian Thomas, who's on the right over there with the red sweater. Yeah, some like it hot. It's room 8. Then we have building secure pipelines in Azure DevOps. Yeah, Leon, where are you? Or is he just, he's gone already. So go to room 7. It's on the back side of your program. There's the rooms, so you can just see it. Then here we have insights and innovations as saving COS. Yeah, with Dennis Mess. You don't have to follow him, he's here already. Sjoerd, who is Sjoerd? Already there, I guess. Room 18, Unbreakable Delivery Pipelines, which is about rollback automated fashion if things don't go the way you want to. And the last one, room 9, 6 months to 5 minutes. Yeah. Have fun, guys and girls. Wacht even, joh. Ja, nee, dit hoeft alleen maar afzetten. Kom maar.
Ja. En we hebben geluid. We have sounds. All right. Let's go and start. To be honest with you, this is the first time to being on such a big stage. And they call it main stage even. I want to thank Coolblue for showing all the fantastic stuff they're working on. But in this speech, I want to bring it a little bit closer to home. Within the Rabobank, at the Department of Savings, we are working on some cool stuff as well. We have automated a couple of regression tests already, and we are working on the delivery pipeline to speed things up. Do we face challenges? Of course. And in this presentation, I want to, show them to you what you could do better or learn. And this afternoon is all about innovation, agile, and DevOps. So in the end of the presentation, I will talk about that as well. And how we make agile work for us and not us making working agile. Okay, I'm Dennis. I'm a tester within the I4IT team. As I'm from today, I'm a public speaker as well. And we have a team who's been working on automating the tests, the regression tests. But the team I'm going to present to you today is a live version of the team that worked on the automated testing, because our task is to set up the continuous delivery pipeline. First of all, we have Geert Hagemans, who is our technical genius. We have Silvio Cacaci, who is our Scrum Master. And we have Bert Meijer, who is a genius officer. Last but not least, we have Angela Abdulhafiz-Khan, who we can thank for the cakes, who were here as well, and very nice. Oh, they're up front now. Thanks for that. She's also our delivery manager and the best product owner I know. As I said before, we are an IT for IT team. Our name is I for IT, so the I's. What do we have in store for you today? I want to take you, like to do a walkthrough. What are we busy on, and what have we done, and where did we run into? First, I want to take you to radical automation and the test automation on the regression testing we've done, how we've done it and where we ran in to. We do the continuous delivery and agile way of work. Radical automation, why should you start? Should have started this 2 years ago, or should plan to do this ASAP. Regression testing, and also the reporting that it gives you, and also the evidence then. The continuous delivery we chose to do with RTC UCD. and how we make the agile DevOps work for us instead of the other way around. Why should we? Well, Paul mentioned it before as well, because, well, the world's changing. We need to speed up. They want us to work agile, but we still have the same IT landscape, which is quite complex sometimes. Our landscape has been around 16 years old, and it's on a mainframe. So less flashy than Cool Blue. When you change only a little thing, it could have, well, a big impact on the testing scope. So that's why automating the regression test should help you to speed things up and to worry about other things. We want to add business added value as soon as possible within sprints in 3 weeks. And if 90% of your sprint is going to be about testing, there is some mismatch. The continuous delivery pipeline is going to help you as well to get rid of some of the manual labor that needs to be done, checking, and so that's why we're focusing on to get that in place as well. Information technology development is rapid. Keep up, and that's the slogan: be twice as fast. Now, you probably heard that before. And that's not the last time you're going to hear that within Rabobank. In the next slide, we made a video on the Department of Savings, just to, well, do a promotion to get all the other departments who are working with the mainframe to get innovated as well. So let's have a look. Some of it is in Dutch, but are there any English speaking? Anders kan ik het ook gewoon Nederlands doen natuurlijk.
What's up with the product? Over there. I'm still busy. Kijk, jongens, we gaan naar huis. Succes in de morgen. Ja, jongens.
The last bit is not really feasible yet, though. Maybe in the near future. But serious, is everybody Dutch or is there some English speaking? All right, okay. Then we just keep continuing in English. No worries. We automated the regression test sets of a couple of the processes we had within AZS, which is savings department. And we needed to take a look at what are the most important processes to get automated, because we have to make small steps, right? What were we looking at? What is AZS? AZS has a front end, and we were looking at the stuff in the square, which is basically DB2, batch jobbing, and services through the front end. We used some tooling to get this done. I'll take you through that. We used DTM, which is tooling that helps us making test flows and then also the test cases. We used U of T with the framework, which is 3.2 nowadays, which is a keyword-driven script via Visual Basics. We used Populate This. This is a Visual Basic script that helps you to load all the data into the databases. We set up a couple of test environments to use this on. And we use RIT to do stops and drivers. So we looked at all those processes and which one were with the highest priority, which were, I believe, 16 in total. And then we started looking at, are there already some regression tests for that? And are they up to date or not? We started using the, no, it was used before, but we started using the DTM to make it all up and running and up to date. This is a small example of well, getting a coffee on our floor, just to give you an idea what it is. Up there we have the specification. You can only get a black coffee, sugar, or milk. So if you want to combine, you need to mix. It's a decision coverage, so you can look at here. You can in the flow we have the decision, yes or no, and that takes you to a path, an action, and an expected result. When you click in the tool on generate, you can choose for the test coverage within medium or high. And after generation, it will give you the test pass with the yes or no, and they were numbered automatically. And it gives you a very fast idea on how many test cases you need to make and which one. You can also generate the test script within Excel or in PDF. This was a very simple example, but you can use it for the hard stuff as well. And it works the same way. If there's any changes within the FD in the specification, you only need to alter this and click generate, and you got your new test paths and flow and test cases. Nowadays, when we are going to create an automated test script, these are the steps we need to take. We need to create a keyword script. We need to set up the test data, think about which test data you need to make the test case work. You need to fill the test data, which we use populate this for. And it's going to be part of the script as well. So every time you run the script, you got the same input. You run the test script and validate the results, of course. And the last step is to validate this by a different tester on another environment. As you haven't left anything out or, well, got something wrong, then you can get rid of that in that step. It gives you great reporting. After the test script has been run, it gives you an overview on how the test cases went, what the results were, but it also gives you the evidence. This is the example of the test cases with the expected result on the left side and the actual result in the middle. And then you can see the past. And there's another link which you can click to see the evidence. There's a couple of them which failed. It will tell you why it failed. And it's very easy then to solve or problem solve what the issue is. It gives you evidence because normally you need to take a lot of screenshots because I did this and this was the filling and now the automated script will make that for you. You can click on the link evidence and then it shows you on what the data was within the tables. Or it can even show you a screenshot on the mainframe. Maybe some people recognize this screen though. Which it says that there's been a comparison between two files and there was no difference. Conclusion. Why should we automate the tests? It saves you time. As Paul from Coolblues told you as well. To underline this, I got a couple of examples. Afrekenproces deposio product. When you do this by hand, it takes you 4.5 hours. We reduced it to nearly 40 minutes. Another example, which is the financial transactions. Normally took you 2 weeks to get all the settings of the test data done, and we now reduced it to nearly 2 hours. FEO jaarwork, which is annual work, normally took you 2 weeks, now 30 minutes. So that's what underlines it saves you time. Of course, sometimes you need to fix something in the script. It's not always pushing a button, and it works. But, well, you've got some time left to fix it. It helps you shorten time to market with the products. It saves repeating actions for, well, the testers don't need to do another regression test, and I've been there, done that, and might not be that focused anymore. Yeah. How many time hours to make the script automated, right? The question was, how many times did it take to automate this script? I'm not really sure. Maybe you know? Silvio knows? I believe that because Gerard did this, I think he did it in a week. Or something around a week. Why? Because we already had some of the general of the keywords we already have, and you can reuse. And some of the keywords need to be well specialized. I believe that we did this script with all the general test keywords. So they only took you about a week. And it saves you money in the end, which can be spent otherwise. All right, what have we done? We did 80% of those high privileged processes, and we finished this last year, or January this year. We created a number of stable test environments for use of regression testing. It's still done by hand, so that's why it's quite an achievement. It's okay. We created 34 stops via RIT, stops we can test against. This was done by the dedicated team, the team where I'm in now, with a couple of others. The keywords were done by one of our teammates, which are the specialized keywords. The other keywords, which are generally used throughout the Rabobank, were created by Radical Automation team, which they can be used by other departments as well, as long as you work with the framework. We transferred the knowledge of making those scripts automated to the other agile teams within our savings department, and they are now doing all the updates or new regression testing. And we had a new focus as from this March from this year. We had a challenge to set up the continuous delivery pipeline via RTC, which is Rational Team Concert. What is RTC? Well, I put it down because I couldn't remember all the definition from Wiki. RTC in a nutshell is Eclipse with a couple of add-ons, plugins. What it basically does is it makes your team, your software development team, collaborate within a tool. This is a simple viewing picture of RTC and UCD within the different environments. The top layer, which brings all the coding within RTC, and you can deploy that via UCD onto the environments using a main branch as well. On the other hand, we had the environment for developers and operators, which is Endeavor. Endeavor will make sure that you can manage your code and release to the mainframe, and it's going to be taken out and be replaced by Urban Code deployed. We needed to come up with the plan how to get this done and to get it into the structure of RTC, because we have 16-year-old coding already. So we needed to make a transformation. Let's have a look on how big and what kind of numbers we are talking about. Because there's been some code written over the years. It's a little over 4,000 EACL members. So it's quite a big application. It's the biggest application that's going to be in RTC UCD for now. We're the biggest ones. So it's a little bit too much to do by hand, though. So we needed to come up with a tool, and thank God we have Geert, who can make great tools. He may transform this, and he made sure that the tooling that transformed all our EACL and all the members underneath within the RTC, how do you call them? Variables. and the standards. Because we're this big, we kept our old job names though. That saves us a lot of time to, so we don't have to adjust all the job names in the schedules. To give you an example, what needs to be done, this is the original. This is the one that's being transformed by transform this. A couple examples, I'm not going through all of them, but we needed to change the OPC application name, which is used to schedule all the jobs in production. That's been done. We put it down that it has been altered by our tooling. And as you can see here, we left out some of the RTC variables, hard thing variables to remember. This is another example of YACL job lib. No, it's a procedure. We did two things. We changed the include member. We used to get all the variables in all the different processes within one include member, which is very handy to maintain then. And also a lot of variables on the top has been gone and changed by the RTC. Okay, but then we need to check it. Have we done it right? Is it okay? We have jammed all the JCL via an UFT script again, and it's about 98% error-free. So we're nearly there. And also the UFT script made it possible for us to retest it within a couple of hours. It only took us about 2 hours to test all the members. Are we there yet? We've got a lot of things done. We did all the transformation on the JCL. We set up all the environments, the new environments which you need. We deployed all the YACL members to the environments. All the COBOL has been deployed as well, and MQ. But we're still not there. We need to test if it's all been done right. So we're going to use the regression test sets we made to see if it runs. And well, it might be that we run into some other problems there. But for now, it looks pretty good. And there's also another question we need to rethink about. How are we going to bring this to production? Because you have the old and the new, which can not run simultaneously. So we need to rethink about that as well. That's another challenge. How do we make Agile work for us, I guess, instead of the other way around? I think, well, that's my point of view, it's my personal perspective, that demos are a very powerful tool to get to know what you've done. So that's why we take this very seriously. Every 3 weeks, we do a demo, and we tell all the other guys, all the other teams under all the stakeholders what we have done, what we have accomplished, what we're going to do in the short future, what the success stories were, and what the goal is going to be. Another powerful tool which we made is we made an overview on where we are, which is divided into the environments and how much is done. So this is nearly done. This is it's a bit older one though. So they can have one overview to have a look on what the progress we made against to the 3 weeks before. We use a wall for the success stories per sprint. and we try to well, do these events and get into mailings to share our success stories and maybe help out other departments who are going to start with this. A key success or the key to success, I believe, is that we had a dedicated team. Besides the teams who do running the bank, the day-to-day plannings, we were out of that. So we didn't have to worry about the errors that would on production. We can focus on automating with the whole team, which is not always true because we have very experienced team members which need to be consulted sometimes. But you put different roles and personalities in one team. I myself I'm a tester, and we have ops and we have development as well. But we all have a different perspective on how to take this on, and I believe that made us better. And we sprint with the goal, made the goal feasible, achievable. Well, it's always nice to achieve the goal and to get a winning feeling. Tell everybody about your success. That's what I'm doing now. And the collaboration with the RTC UCD team is great. They got a lot of knowledge, very willing to help with the different kind of issues we have because of the big application we are. They haven't done that before, so there's new goals for them as well. Are there things we can do better? Things we would do differently today? Yes, of course. Regarding to set up the regression test script, the maintenance of the test script is done by the other agile teams, but you really need to think about that it doesn't always get priority one. To be more frank about it, it very often doesn't get priority one, not two, and it gets to the bottom of the list. You need to worry about that because otherwise you've done this all for nothing. I feel we need to convince the business even more why twice as fast is needed. We heard in the Cool Blue as well that it's a mindset. And I believe that the business knows already, but do they feel it as well? What's in it for them, you know? Regarding to setting up the continuous delivery pipeline, I would have stayed a little longer in the sandbox. We got a sandbox, educational environment, which we could play in. And looking back, we should have stayed there a little longer to test the tooling. It saved us. It would save us a couple of runs. We did 14 runs, and now it's fine. But we did 14 runs. We make sure that the step that's coming, when we're done with the setting up the continuous delivery pipeline, and we have done the automated scripting, I think you need to join them. Otherwise, what's the use of doing it at all? Okay, that's the ending of my walkthrough. Are there any questions about the stuff I said or?
Look at the effect of all the factors you put in here. What's the most appreciated?
Well, the most appreciated effect for me is you don't have to do everything by hand again and again. When you look at the regression test sets, they can be quite big, and you've all done it before, and you're not as focused as before. And now you have a different perspective of that because you can focus on what's not going right. You either need to make the script working, or there's something not right in the code. I think that's the one that's for me the most favorable. I don't know actually, because we are not in that team, and I've been in Rabobank for a year now, so I don't have that perspective. If we do that faster now, I don't know. Or we might if we get the continuous delivery pipeline done. Yeah. We have an example of the FJL jaarwerk. We had a bug in the jaarwerk, and we needed to do a fix, and then we ran the script, and it only took us 30 minutes to do the testing and to give a confident feeling that it's fixed. And normally it took us 2 weeks to figure out if it's done right then.
The last example, did you then add a test for that bug that you fixed? Then ran the test?
No, we didn't. We didn't have to though.
Why didn't that?
No.
I think the response to my actual. Why did that add? And then still be confident after
We didn't have to alter the regression test set because there was something wrong in the jobs were run differently on production than it should have been. So that's why we didn't have to add a test. Yeah.
And so, so then can you feasibly do architecture? Actually do that. So I don't know if it's does
No.
Okay. Does it give you options? Like there's a lot of programming.
Yeah, it does. Yeah. Okay. No more questions? Well, thanks for your time and your interest. And if you want to know anything more, you can run by the floor on the 23rd on the towers to do a demo, or you are more than welcome to. All right, thanks.
Test, test. All right. Hi everybody, my name is Arno Keuler and I will be talking about consumer-driven contracts. First off, a question, which one of you are developers? So the other guys, testers maybe? Over there. And the other ones that are not raising their hands? All right. Those are your words, all right. So small intro. My name is Arno Keuler. I work at a small company called Source Labs, and I'm currently hired by the mortgages department of Rabobank. Yeah, we are mostly doing Java, but we are also very interested in Kotlin, GraphQL, and all things Spring. Yeah, we're a fun young team. We're just 1.5 years old as a company. And as you can see, we have the same vision as Rabobank, that you should have fun at work, since we have a play seat, and we have expensive deals and meals and everything. So, consumer-driven contracts. Which one of you already knows the concepts of consumer-driven contracts? I see 2 or 3 hands, all right. I have a relatively short presentation, so I can dive into the technique a lot more. So we'll see where we get. So let me start. I started 1.5 years ago at Rabobank and working on a big monolith called MOA, Mortgage Advice something, Orientation and Advice. And it's a big monolith, so there was a big process. We go live every week, and every week you'd be the release coordinator. And as a release coordinator, it's your mission to find a stable build. This means that you have to have a green pipeline. So there needs to be a build where all the new code is in, and end-to-end tests have to be run. Everything has to be green. And usually, if every team tells you that they're done with their features, it takes you at least 2 days to find a green build. And after that, you have to get acceptance from all the product owners that on the test environment, they tested your version of the application, and it was good. And then there's acceptance from all the 6 teams that were working on MOA, because maybe you broke something in one of their specific areas. Every team had their specialty area. So there's a lot of validation going on before we could pick a build. And this takes a lot of time. Not to mention the time of going live. I don't know which one of you still has the same kind of process, but for us it means you have to be in the office at 6 or 7, and you go live, and yeah, you're basically kicking off automated deployment and waiting till everything is fine, and all the product owners again tell you, well, everything's working and we're happy and the release is done. So does it sound familiar? A lot of you guys, I think so, right? I don't think it. For me, this was the most hateful process ever. Being in such an application that just way too much time of just picking a build and going live. So what's the answer? Well, microservices. Microservices, I think we all heard it. We all might be moving towards microservices. Who of you is? Already has a lot of microservices on live? All right, 1 or 2 hands. So with microservices, you're actually splitting up your application into smaller business valuable features to together have this working system again. So does this actually make it easier? Well, I think not. One could argue that we have a microservice over here. It's a fine-grained networks working together as one system. So why do we actually want microservices? Well, I asked my friend Wikipedia, and it said, well, the philosophy of microservices is essentially that you do one thing and you do it well. This takes some changes. This takes some changes of the organization. You need to be resilient. You need to be composable. You need to be small, and you need to be anti-fragile. So this also means that you have to think about concepts of, I don't know if you're all familiar with that, circuit breakers, for instance. Who of you know circuit breakers? Yeah, so there's Hystrix from Netflix, and those kind of systems, you got to implement them to do microservices. But there's also another thing. And if you look at it, it says, well, the organization must embrace automation, testing, and deployment. Well, automated testing and deployment. Well, I guess that's why we're all here, right? Automating testing and deployment. So the benefit of microservices is doing one thing and do it well. And that actually enables us to work with multiple teams on your own feature or on more easily comprehensible features as a system. And to go live more often, because you automate everything. And for our microservices, for instance, the ones we have a couple now. For instance, we are building our online advice, our new pieces of online advice in this new microservices way. And we're going live actually a couple of times a day because we automated everything. Funny resemblance. I don't know if you know Conway's Law, but Conway's Law says a company that creates software creates representations of the organization itself. And for instance, if you look at Microsoft, which is a very imaginable company, I guess, you have the Office company, you have the guys building the Windows application, and actually they're all guys saying, yeah, what they're doing over there sucks. So if we look at this, there is one type of company or organization that does it a bit better, namely open source. Since communication is expensive for these guys, you have to be more modular. You have to make software that has better interfaces. So they make better agreements. Because when they communicate, there's not much time to communicate. If you got to talk to the guy in Australia, yeah, there's like a small window to really talk to that guy. So what they do is narrow down the conversation to be the conversation, to let the conversation be about interfaces or contracts. So you don't end up with this. So right, we're doing microservices, and the aim is to be scalable, loosely coupled, more fault tolerant, scalable, a lower cognitive load because we're more fine-grained, so we're doing one thing and we do it well. And this enables autonomous teams to do continuous delivery. All right, fine. So let's build an API. Let's go. You go sit together in a room, you define your request, your response. And then, well, that moment happens, end of the sprint, and everybody's happy. Works on my machine. Now let's go to production. Oh shit. What happened? It blew up in your face. It turns out the API you built actually had consumers. So you were building this thing, and during development, you made choices. You changed the field name of something, or you changed the structure of your response. And yeah, how do we know your consumer actually picked up on this? I mean, do we talk it every day to each other, or what? Well, as I said, in the open source, they don't have that luxury, so they do it different. Well, at least we can say that we should write more tests. You know, we should test the situation that it works. So then arises the question, at what level are you going to test? Anyone an idea? When we're working with microsystems or microservices, where do you test? At what level of the test pyramid? Does everybody is familiar with this test pyramid, right? Can show hands? All right. So at what level of the test pyramid would you lay your tests for integrating with other services? Anybody an idea? Integration. All right. But that's within your application, right? That's if you integrate. So, and usually when we look at microservices, yeah, we're actually looking at integrating between other services. So how do I build that? So actually, if somebody recognized the images, they're all from Martin Fowler. And he wrote an article called Consumer-Driven Contracts. And it's a concept where, is everybody familiar with what I mean when I say contract, actually? Do you have a feeling what a contract is? Yeah, but if I look at soap, what's my contract? Then it would be the XSD, for instance. So we're actually looking for a contract, only consumer-driven, so it has to be a bit more loosely. The idea is to have, well, as a producer, I produce this response, right? And I have different consumers. All might be interested in different parts of my API. For instance, this service only cares about the ID and the name. This service there, on the other hand, actually is interested in the ID and the age of what my producer produces. And then there's application C, which is like the user page or whatever, and it's actually interested in the entire response. So together, all these contracts define my, my contract as a whole. And it might actually provide you with some interesting insights. You might find out there are some features unused of your API. Your API team thought of a lot of functions that were really useful in your mind, but in production, nobody's actually using it. Or you could find that you have some unmet expectations. So using consumer-driven contracts, you can get into this situation of having more insight. So how does it work? Oh, I'm sorry. You actually said, who said that? Someone over here said that it's integration. Yeah, so you were actually right. What we do with consumer-driven contracts in a practical way is actually define contracts that test the part between the external service and the application itself. So you define a contract and you validate during development time that you're actually still fulfilling the contract with your consumers. What we actually do as a team, within my team, is actually write an integration test for the entire application. So I don't know if you usually build a Spring integration test. I guess you're a Java developer, right? Or no? All right. Any Java developers? All right. So what we do in our team is, if I say an integration with Spring, is that we build an application and we mock away the repositories as mock beans. So we have static data to test against. And then we have the contract over here that we can test and validate that we still work up to the contract. All right. The framework we use for it in Java is Spring Cloud Contract. And I already told you my company is interested in all the things Spring does. But actually, I think of all the options you have, the other option would be Pact. And for other frameworks, I actually don't know. I'm specialized in Java myself. But for me, Spring is a lot more easier, and it provides me with a lot of simple, easy to understand concepts. So what Spring provides is actually a DSL, so a domain-specific language to define the contract, which is easy to read, and we'll dive into that later on. A wiremock stub generated from this contract, and auto-generated tests. So my producer is actually automatically tested against this contract. So what I do in my team is I allow my consumers to actually write contracts within my code base, to actually let them write contracts in the DSL and commit that to my code base via pull requests. And well, then later on I can test my application if I actually met their expectations. Immediately, there's also a stub application generated. I will go into the code now. So let me set it on presentation mode. This is an example of the DSL Spring provides me. It's in Groovy, and I think it's pretty easy to read to see what we're doing. It says contract make. I have a request that has a URL. The URL looks like this. I get an accept header that is an application JSON, and I expect a response of 200 with a body of ID 1 to come back. All right, let me first show my application because I made an application and I need to see what we're talking about. So actually I have an API, which is really silly because it just has an orders and it just has the only to get the orders. So the only thing I can do is actually say, well, I have an orders 1 and it gives me back the ID of the order. Really stupid application, of course, but it's what it does. And I have a client, and as you can see, we had some cutbacks on our design department. So it's a very dumb client. And I say, well, go to the order with ID 1. And as you can see, I get the order, and the only field in there is the ID, so only the ID is filled. And our front ender said, well, the order might have a total price, so they actually filled in the price already in the screen. But this is what the application does. So here's my Swagger API defining what my API does. I think this will be familiar. Is this familiar for everybody? The Swagger, no? Yes, no? All right. Swagger is actually a framework that enables me to get a sort of a documentation of my application very fast. So I just put some annotations on my application, and this is just generated from it. So I can see what are the models going in and out, and what operations do I actually have on my API. This is the wrong window. So as I said, this is the DSL for it. So as I said, I define the request and I expect a response. Now what Spring actually does for me is generate a wiremock stub. And this is what it looks like. It's just a JSON. Who of you knows wiremock? All right, so wiremock is just an application that actually is nothing but a mocking application. You give it a JSON and it knows on what request it will serve what output. And this is actually what is the JSON that is generated. And if we then look into the tests, these tests are generated by the framework. So from the contract you just saw, a stub is created and these tests. And these tests are just validating my application. So I can run them. After a while, you see everything turns green, and we actually fulfill our contract. Is it clear what I'm doing here to everybody? Raise of hands if it's totally not clear. Okay. Ah, right. Well, let me put it like this. In our code base of our server application, our API, we actually defined a contract, and those contracts are just as simple as saying, well, I have a folder here in my resources, and well, everybody can make these files. I got 3 files over here. Can you see them over there? Yeah. And these files actually specify that if I get an orders 500, that the application will throw an error. If I get an orders 404, the application will throw an error. And if I have an orders number 1, then I will give a real result. These are 4 scenarios that I could program in my API to do validation on my API that it really does what it needs to do. My consumers, on the other hand, will get the generated stubs. So these JSON files I showed you, they will be able to be, they will be generated into a jar file over here. And the jar file is shared via Nexus. So every consumer is able to import this jar via Nexus into their application. And what they can do based on that is actually a very, for a Java developer, simple concept of creating a test and saying, Well, I enable the stub runner, and my application will do a Spring Boot test. Everybody familiar with Spring Boot, by the way? Otherwise, this is total rubbish. But all right. So it will spin up a Spring Boot application of my client, and it will run the test against a stubbed environment. And that means if I look over here in my properties, here I say, oh, that's the wrong mode. That's not the view I wanted. That's the view I wanted. Here I just define, well, I have a dependency on a jar called NL Source Lab Spring Cloud Contract demo with the jar name producer, and I want to run it on port 9898. Here I set a plus, and that's saying actually that I'm not interested in the version, I just want the latest. You do want to notice, by the way, that if you're using Nexus, Nexus has a cleanup schedule, and it's not always correctly updating the metadata. We found out that we cannot use in our project the plus version, which is a shame because it's very powerful. It just says, well, give me the last version of the API and see if I still am compatible with it. So right now we have to manually put that in the POM. For the people who understand Maven, POM file is a descriptor of your project. Sometimes I go too fast, I'm sorry. Yeah, so I can now see that if I run this test as well, which might not be the interesting thing to see, that also my consumer is validating itself if it's still able to talk to the API. And right now it's not. Let's see why not. Stubs weren't found on the class pod. All right, and I have no network, so I cannot fix that right now. That's bad. Let me first go into a change. So we saw this application, and we saw that, well, right now only we get an ID, right? So the only thing the order has is an ID, which is not very useful. We want the total price as well. So let's change the total price in the application. By the way, I wrote this in Kotlin. I hope somebody already know what Kotlin is, but here we go. So I have a data object, an order object, and I just gave it a total price with a default value of 0, 0. And well, let's rebuild the code. As you can see, I'm enabling Swagger in my application, and it's a very small application just serving out 3 options. You can get an order if you have any number other than 500 or 404, and if you go 500 or 404, we throw errors. That's basically what my API right now does. As said, it's not really exciting. But we added the total price. And I'm actually doing it the wrong way around now because I was going to show you consumer-driven contracts, so I should change the contracts first. So this is going to fail either way. No. Which is funny. Oh, no, because it's still valid. The response is still valid. It's able to filter out fields you don't want. So the other way around is better. I'm sorry for this. Demo gods, I'm sorry. The other way around, I say, well, I expect a total price over here to be, and I have a fixed total price, for instance, over here. I expect a total price of $34.99. Right now, when I will redo what I did, my API will fail because the total price is a new field and it doesn't know it yet. There we go, that's better. So you see what happened underwater is actually it wrote new tests. So we go to the test class and we see here that it now expects a total field to be there. Is everybody able to read that, or should I go to presenter mode? So, right. So what you see here is that these are generated tests. All you have to do is provide a base test where you say, well, I have an application context and I use rest assured mock MVC to set up my application on a random port. This, by the way, is very, very important if you're using, for instance, Jenkins or something to to set up your test, to run your test. Because if you use Jenkins, a port might be blocked. And by using the random port, you actually almost never get into the situation where the port is already existent. So if we look in the test, we can now see that if I run this again, also in the IDE, it will fill. And that's because my API doesn't provide this field yet. So this would actually be the moment I get a pull request from a team. They change this contract in the Groovy file. And by applying it, the pull request, I see that I break. So this would be the moment to talk to the consumer like, hey, I see you expect a new field of me. How are we going to do that? What do we need to build? And this way you can have a useful conversation about changes in your application. So what I do now is, as a provider, I change my data class, my order class, and say, all right, so right now we have a total price. And if I redo my test, I have to rebuild, I'm sorry. So as you see, I have to use Maven to really regenerate my code right now, because I think I did something with the Kotlin interface, but this is distraction, I'm sorry. Wait. Oh, I forgot. My demo was actually expecting a fixed price. So I needed the fixed price over here. It was getting 0, 0. Now I'm saying over here in my code that for order ID 1, I'm giving a price of $34.99, which is not really a life-like example, but usually you will do this by mocking the mock beans, by mocking the repositories and saying that for this ID, you will get that price. So usually you will set this up in your test setup, of course. Right now I'm doing it in my code. And now if I run the test again, it will work, of course. So who says I don't understand anything that just happened? Oh, luckily, that's good. Yeah. How do they know? Well, there's as I said, you also generate a mock. So what happens here, good question, by the way, thanks. What happens here on the water is that when you run Spring Cloud Contract, it actually has a Maven plugin that is able to convert your contract that you define over here into a JSON that can be used in the WireMock application. So there's a WireMock jar, and you can see that over here. That's called stubs. And as a client, you can depend on that. So if you look, I actually have 2 applications in here. I got my producer. I will contract it now. And I have my consumer. And the consumer actually has a test over here that says, hey, enable stub runner. Wait, I'll make this a little bit bigger. Enable stub runner server. And it's a Spring Boot application. So I just start up a Spring Boot application test. And I let it run on a random port. And I say, well, I start my consumer application.class, and it's running. And in my test, I say, hey, do the checkout with 1, and I expect the following, the order to get an ID of 1. What you see here is that I didn't change my contract to work with the total price yet. I could do that now, but I think the chance of that going wrong on demo place is bigger than it will work. So, and what you could actually do, which is quite funny, is also use this stub to test your application, like for real. So not, if you look now, right now, I'm actually testing against a real backend. I'm running both applications on my computer. So if I go to the run console over here, you see I have my producer running. Right now, if I kill my application, you will see that my client application actually throws an error because it gets no response. So during development, it's really annoying if you have a really big microservice architecture to have all these applications running during tests. You don't want that. You want to test your application. So what you can do is actually say in your application properties that you run a different profile, which I call stub. And then I have a stub property saying, I will increase this again, that I depend on a different library called NL Source Lab Spring Cloud Contract Demo Producer, and I actually want the latest version to run on port 9999 during my stub profile. Also, you'll see here local, that means that it's looking to your local Maven repository. I could say that it has to look to remote, so it will actually download it from the remote repository. And there's also a class path option, so I have to package it. For me, local is mostly the most convenient, but there are situations where it might be different. So right now, if I start my application again, my consumer application, I have to restart it. So it's over here. I say restart. Right now, it will also spin up the WireMock application. And I can go to that WireMock application because I told it to run on port 999. And if I go there, you see these are all the stubs I have on my stub application. So it has a lot of mappings, and it says, well, I have this mapping, that's an ID of orders 404, and it will receive, transform, it will give you a response of status 404. Over here, I got an order 500, and it will give you a status 500. And I got an orders 1, which will return you the body with a total price of $34.99. And if I go into my application now, and I go back to checkout number 1, you will see that I get ID is 1 with the MOX price of $34.99. So you're actually able to use this mock application that is generated by the contract during development to test your application, which is really powerful. Actually, this is, I think, what I wanted to tell you. So we have a lot of time, I guess, for questions.
The question is, in most cases, right, like depending on I think this would suit the need, but this is a good idea when you have like the service in control, like people on some service inside your department, then you can ask them to. But most cases, we depend on other external services. There is any strategy to.
Yeah, I actually talked about the model of pull request into my own repository. So consumers write into my repository. There's another way. You can also say that you have a different repository, and from there on, you're going to build the contracts. And so nothing is failing unless you depend on the contracts. So as a producer application, I then have to create a dependency on the other repository, and I can do exactly the same, but I decoupled my contracts. I just have to say I depend on that version of the contract. And that way, you're also able to make a contract for an API that you cannot control. Because you know those contracts, you know what the contracts should be, and you can generate their stuff for them in an easy way. It's an option. And then if they have the tag, they can later connect to it. If they right now say, yeah, we're not going to do that, and you can build something for yourself. So you have a way of testing it and validating. And it's a thing colleagues of mine did at bol.com, so it's an option. Yeah, well, actually, what I just did, if you look at here, I actually said that in my application of properties, I told him my active profile, my active Spring profile is called stub, and therefore it's now running stubbed. So you could do that. You could have like a load test profile for on the Jenkins build to test against the stubs. And I think even WireMock has a feature that you can set timeouts. So you can actually play with that as well. So you can test your application if it has longer response times.
Your presentation, you mentioned something about identifying new requirements for the
Mm-hmm.
the market. Consumer will give you new ideas and new fields.
The other way around. Your API should give you those new fields, and as a consumer, you expect them.
So who initiates that, consumer or is that the API user?
Well, in the way we work, everybody is allowed to create a contract. So everybody's allowed to create a contract in our code base. They just have to deliver it on a branch with a pull request. Yes. And then we get a pull request saying, hey, I made this. Can you review it? And then we review it and we say, yeah, but we don't have that. And then
I was talking about, thinking about the you can offer it and then find
and then I assign a Jira task to it and I say, well, there's a pull request, there's a branch, and whoever picks up this task will look at that branch and that pull request to merge it in and to fix it. Exactly. That's the way we work. What I said, it's also possible to work with a third repository and then work version-wise, but for me, that's just a lot of hassle.
No, we should change the contract and immediately I saw because errors are built. So
Exactly. So that's why you make it a pull request. You make it a branch, and on the branch, you can just let it be there for as long as needed until you implement.
any opposition to which to microservices. I know a few years back, not everyone.
I think our department is a little bit different in that. We're always a bit of the wild boy or the persona non grata in the Rabobank, I guess. I mean, we also had Meses Marathon instead of waiting for Pivotal Cloud Foundry. So with us, it's not that big of an issue. We just started doing it, and yeah, this is a tool that helps us do it. All right. One more question then.
There's also Swagger definition. It says also the definition of the API. What's the difference between?
Well, Swagger is generated. So Swagger is just for consumers to see what I got. It's actually just exposing what I already have built. If I go to Swagger, it just says, well, this is what is there. Exactly. No, well.
From consumer driven, you can also do the request, I want to have those files and send a new contract.
Yeah, and it's actually a way to test it, because the thing I forgot to mention, which is most powerful, is right now I'm testing it within my build. I'm doing it while I'm doing Maven clean install. So I'm actually detecting issues like this during development time instead of on an environment where I have to have the right versions of all the applications running. So that's actually the benefit of doing this. You see this, the moment I rebuild my code, it breaks and notifies me that I do not fulfill the contract anymore. Yeah? All right, thanks everybody.
Yeah. Chris, everybody's in? Good enough? Can we start? Okay, 2 minutes. 2 minutes.
Yeah, right. Yeah. And then I must go oh, that's so funny. And then, right. Okay, so you read that? Yeah. No, I just read it. Oh, yeah, I can. That's very funny. So it was just, how do you call that? What you do is if you have an extra. Oh, cheating? Okay. Don't talk Sarah. It's just doing your homework. Yeah, during the event. I love it.
So, 2 minutes are over. So let's start again. Yeah. We have 3/4 of an hour minus 9 minutes. Yeah. And I'm honored to have you here, Jeff. Jeff is program manager, yeah, of the Azure DevOps environment, Visual Studio Online. I wanted to say first, but then it was VSTS, and now it's Azure DevOps environment. And he will tell us all about your journey towards the DevOps culture. Yeah. I'm happy to see that you're all still here because it's the third event, and the first two were all crowded, but the final plenary meeting always was kind of half full. I had some worries about that. You're all here still. This is really good. We just used one email and everybody was there. We were full, and now we're at the end and you're still here. So there's a lot of promises there.
That's fantastic.
Yeah. Have a game.
All right, thank you very much. Let's see, so mijn naam is Jeff Baylor. Ik woon in Leiderdorp, maar ik spreek een beetje Nederlands. So the rest of this will be in English. I know you're disappointed, but you don't want to see me struggle through my Dutch. Yeah, so I'm a principal group program manager with the Azure DevOps team. Every once in a while, you'll probably hear me sort of slip up and call it the VSTS or VSO team. We have been through a bit of a transformation in terms of our branding. Hopefully this is the last time because it gets confusing to people. But yeah, so we're now the Azure DevOps team. And I'm not going to talk much about our product because really this is more about the cultural and process-related changes that we've made, not as much about our product, but I think it does help to understand a little bit about what we do. And so we're a collection of services meant for teams that are embracing the DevOps mindset and culture. And so we've got a series of capabilities associated with planning and agile transformation, as well as code, so Git and the version control repos that you might use, builds and the release pipelines, managing artifacts, as well as tests. And so those are the 5 major services of Azure DevOps. And this was a recent rebranding that we did towards the start of September, so we're about 3 weeks into it. And as you can see there, we've got each one of those are separate standalone services, but they're really better together as teams really use it to work through their entire life cycle of developing and deploying and managing services, both on premises and in the cloud. Our team is about 850 people around the world, and you can see we've got 4 major locations, including, of course, the Redmond area, as well as San Francisco, Raleigh, North Carolina, and then Hyderabad, India. And of those 800 people, there are about 40 that are like me who work outside of one of the main offices. And so while I live here in the Netherlands, I really work with the folks in Redmond. So I use my time, I time shift my day so that I work late afternoon and deep into the evening in order to have good synchronization with them. We are a team that has been together for a long time. We used to be, and we still release Team Foundation Server, which was first released to the world in 2005. So we've been through a large transformation from an on-premises product that gets delivered every 2 or 3 years to a service that's now delivered every 3 weeks. And so we're on a 3-week sprint cycle, and our team is always in the process of creating the next version, which is just 3 weeks away, and that then gets deployed, new features and all, to our service in that same time period. Now, those deployments happen like clockwork. So you can pretty much set your watch to our sprint schedule. We never change it. It's always 3 weeks in length. We then take a collection of those sprints and repackage them into our on-premises product, which today is called Team Foundation Server. And then that's released on approximately a quarterly basis. And it's all from the same source base. And so that gives us the ability to be able to deliver that value and those improvements to our customer base across the spectrum of deployments, both in the service, which we run ourselves on Azure, or for our customers that run it on their own hardware in-house on top of Windows Server. And so this just happens regularly like clockwork, time and time again. This isn't where we started, though. We didn't start in a world where we were like clockwork on our deployments. Instead, where we started was a process of approximately 2 years, which started with a planning cycle, which sometimes took up to 4 or 5 months in length. And during that time, we would work through all of the big, long specs and do a bunch of reviews and talk to customers and try to understand what it was that they needed. And we would get to the end of that planning cycle, and we felt like we really knew what we wanted to develop for our customers. And it was well informed by all of the feedback we had gotten, and we felt really like, yeah, okay, this is a winning product. And then we embarked on the process of actually implementing and getting that out to customers. So we'd code like crazy for the first milestone, and then it would take us quite some time to pull all that together and integrate it, stabilize it, and get it ready for release to customers. We would then release what we called a beta, and that release would go out to customers, and that was with great fanfare. We were really excited. It was a go live, and so it allowed customers to then adopt it, run it in their environments, and send us a bunch of feedback, which was great. Like, we'd get all this great feedback. But the problem was that this feedback was ideas and corrections and fixes and whatnot for the current product. But the current product was already well underway. We had everything planned out, and you remember the planning cycle fully booked all of our time. And so that time was already booked. It was already spoken for. And so this feedback really turned out to be something where we couldn't handle or really respond to that until the next product cycle, which was enormously frustrating for us as well as our customers. And it put us in a situation where competitively we just couldn't keep up, because the market kept moving and the demands kept changing, and we kept sort of missing the mark because we were planning so far in advance and unable to execute in a short amount of time to deliver that to customers. So at the time, it was okay. Like we were in the early 2000s, we were able to be competitive because we had a lot of really great value we were bringing to customers and integration and whatnot. But then as the market moved and towards open source and a whole bunch of other sort of competitive changes in that space, we were unable to keep up and really pivot when we needed to. So we've made a bunch of changes as a result from that model to the one that I'll describe to you. And here's a quick listing of a bunch of things that we changed. I'm not going to go through all of these, but you can see that we've really changed almost every aspect of our business and of our approach, which has had a really deep sort of implication on our team. At the end of the day, the changes that were most impactful were to our culture and to the way that we perceive the work that we're doing, the way that we work with one another. Because at the end of the day, that's what really impacts how work gets done. You can change all the process and tooling that you like, but if you haven't changed the way you're thinking about it and really trying to be more agile, learning along the way, always improving along the way, then those changes in tooling and process will likely sort of run their course and not continue to improve. Here's a representation of the number of features that we've released in the last 6 years. And you can see that it's greatly escalated over the time. And this is a representation of what we think of as one of the real benefits of the changes that we've made. And you can see here that in 2016, we delivered more features in the 2016 calendar year than the previous 4 years combined. And in 2017, we delivered even 66% more features than that. And so we're on a real tear in terms of really increasing the velocity of delivery to customers and the improvements that we're making. And so let me tell you a little bit more about how we've done that. At the end of the day, as I mentioned, culture is the key thing. And for us, one of the key aspects or key concepts that we have in that regard has to do with something we call aligned autonomy. And you'll see me use this triangle a few times throughout the presentation. And really, the struggle here is about keeping a balance between alignment and autonomy. Remember, we have 850 people on our team. And so keeping them all moving in generally the same direction is a really interesting challenge for us. So that scale has really pushed the work that we have to do towards aligning that, aligning the team while still giving them necessary autonomy. There were some times through our process that we had what we call too much alignment. So too much top down. And what that really forced or caused to have happen was, there was a lot of top down, here's all the things that you have to do. And it really impacted the velocity of our teams because they're always waiting for some approval or waiting for some sort of top-down mandate in order to make progress. So, as with many of these things, there's like a pendulum. And so it would swing back to a situation where there was too much autonomy. And what would happen in situations like this is we would wind up with too many UI testing frameworks, right? Because each team would go off and say, I'm empowered to do what I need to do. And so they'd go off and invest in some of these areas without really talking to anybody else. They just go do what they felt like was necessary. And it caused a lot of waste in the system because they wound up investing in things that were duplicative of other teams or not really coordinated with other teams. And so finding that balance between top-down mandates and bottoms-up empowerment is really the challenge that we faced as we've made this transformation. And so as we look at the various aspects of running our team, we have identified certain things that really are things that we hold true to be true for everybody on the team versus those things that we enable teams to do on their own. And so vision, role, and cadence, we all share a common calendar, for instance. We all share a common vision of where we're going. We all share a common sense of the roles within our teams. Like that's something that we share across. But then the things below the line are things that we really enable our teams and empower them to do on their own. And so The makeup of the teams is really up to the individuals. The plan, the way that they actually attack and organize their work is something that they do on their own. And many of their practices within their teams are things that they are enabled to do on their own as well. There's an excellent book called Drive. If you haven't read it, I would highly recommend it. If you don't have time to read it, there's a great YouTube video. Just Google or Bing, Daniel Pink. Bing, Daniel Pink, and the word drive, and you'll find a great representation of his concepts. And at the end of the day, basically what he's doing is he's done a bunch of research into what really motivates people. And what he's found is it's not the typical sort of rewards and punishments that we think of, but it's really more about autonomy, mastery, and purpose. And so if you can find a way to enable teams to pursue autonomy, mastery, and purpose, they're going to do a lot more for you than if you've got the whip out and you've got some sort of rewards that you're trying to drive for. There's a great story in his book, which I'd like to share with you, and it's about two teams. Team number one has an excellent business plan. They're well established in the market. Everybody's heard their name. They're well funded. They've got all the money that they need in order to be successful, and they've hired the best people. Team B, they're working for free. They're doing it in their spare time, and they're doing it only because they want to. Now, as a business guy, I look at these and I go, I'm going to bet on Team A every single time. Well, it turns out this is not a hypothetical example. It's a real one. And it's the example of Encarta and Wikipedia. And here's the Wikipedia article on Encarta. I probably don't need to say more. But you know, the forces of autonomy, mastery, and purpose really made themselves clear here, and has really changed the way that many of these sorts of projects are done. And so we've embraced this idea that autonomy, mastery, and purpose are key to our culture. And so you'll see that come through in a lot of our practices moving forward. So we changed 4 key things on our team. We changed the way that we sort of run and manage our teams. We changed the way we plan and learn, changed the way that we stay healthy as a team, and we changed the way that our code base works with our team so that it also enables a lot of our DevOps approaches. So I'm going to go through each one of these for the rest of my time here with you today. So let's talk about the teams one first. This is the way our teams used to look in terms of an organizational structure. We had 3 key functions within our org. We had program managers. I'm a program manager. We had developers, and we had testers. And so, you know, program managers would write the spec, developers would write the code, and testers would test the code. What we found was that having this split between development and test produced a lot of bad sort of interactions, because it relieved the developers of the responsibility of the quality of the code. They could just throw the code over the wall and expect that somebody else was going to find all the bugs. And it just set up this really unhealthy sort of experience between the two. And so what we've done is we've eliminated this notion of developers and testers. And we just have engineers. And engineers are responsible for the quality of their code as well as what it does, the functionality. So it's not like we certainly didn't go off and fire all our developers or fire all our testers, but instead what we did is we integrated the team so that the former developers taught testers how to write code, and the former testers taught the developers how to test code. And now everybody does the full gamut of responsibilities. It's not like we just sort of changed everybody's nameplate, but we still just have people that just do testing. It's really like everybody on the team is responsible for feature development and for writing the code. Program managers pretty much stayed the same, but one of the aspects that has changed is that the program managers used to be the ones sort of managing the schedule within the team, doing a lot of the checklists of tasks, making sure people were doing their jobs. That's no longer what we do. That's really the responsibility of the engineering squad, to manage their own work. Like, that just seemed crazy at the time, but it's the way we do it now. And the program managers are more focused outward. Who are our customers? What do they need? What's our strategy? How are we going to meet those needs? What's our priorities? What's the design of what we're going to deliver? Those are the sorts of questions that program managers answer and ask these days. And so we organize around the functional boundaries, but in the end, it's really the members of those feature teams that sit together. And so oftentimes our feature crews are on the order of 10 people or so. 8 of those will be engineers and 2 of them will be program managers. That's generally sort of how we do that. And we sit together all in a common room that has good walls and good doors to them, so that the noise that developers and engineers are dealing with and program managers is the noise within their team, not the sort of bad noise that comes from large rooms. And so teams are entirely empowered to decide how they want to organize their rooms, what their rules are for the rooms. And then around each of the rooms, there are focus areas and conference rooms that allow them to separate if they need to take a phone call or work on some deep technical thing that requires 0 interruptions, or work as a team on stand-ups and whatnot. And so it's worked out really well for us to sort of transform our space as part of this this work, because we used to sit in offices, like single-person offices, and those doors eliminated the ability for folks to have good conversations amongst each other. And so we worried a bit as we made that transformation that people would flee the team because they really enjoyed having their own offices. But now when we talk about the possibility of moving to somewhere that has offices, like, there's the revolt. They say, no, we need to work together as a team. I can't imagine being in an office all by myself. The other thing that's important about the sort of team change that we've made is that the engineers are responsible not just for writing in the quality of the code, but also the deployment and the running of the code. It's not like we have a separate ops team that's off, running and dealing with any issues in production. That belongs to the engineering team. And I'll talk a little bit later about how they deal with, sort of the 24/7 responsibilities associated with that. But at the end of the day, they do have that responsibility, and having that full end-to-end sort of view of how the code is running and what the customers need just really provides a great bit of input and empathy for those engineers to really do their best work. Another change for our teams has to do with the way that we organize the sort of the technology that they were working on. Previously, we had a lot of horizontal teams. We would have a team that was just responsible for UI, or a team that was just responsible for the database layer. And then if anything needed to get done, like a new feature, there'd be some coordination that would have to happen between those teams in order to make that come together. And those dependencies became a real barrier to high velocity for the teams, because there was all this coordination, and the program manager was running around trying to get the right people to do the right work at the right time, and it was really just a coordination nightmare. And so we've really worked to change the way that the teams work so that there are UI, API, and data experts on each of the teams, and they are responsible for the full end-to-end delivery of a particular piece of value for customers. So the team, when they decide we're going to go work on enabling a new scenario, they've got the ability to deliver that completely independently of anybody else in our 800-person organization. And so that's really enabled them to have a much faster time to market for any of our new features, because they don't have to do a bunch of coordination across the teams. Now, of course, the downside here is that now you've got database experts and UI experts sort of spread across through the entire organization instead of having them sort of birds of a feather together in a common area. And so there is some coordination and work that we have to do in order to ensure that there's some consistency across those teams in terms of how, sort of standards for API development or UI development. And we do have individuals who have more of a horizontal responsibility, but the first and primary orientation is vertical. And then we patch that up, any sort of consistency or standards-driven things with horizontal subject matter experts. We also have self-forming teams. And this was an important innovation for us because in the past, what would happen is when it came time to change our organization, we'd get all the managers together and we'd sit and try to figure out who was going to go on whose team and how we wanted to organize these things. And then there was a big reveal at the end where we'd say, okay, here's the new organization. And everybody would sort of learn all at once without having a chance to give much input. We decided to change that completely by instead saying to the teams, you decide who's on whose team. You tell us which team you want to be on, and we'll do our best to make sure that that happens. And so everybody gets these yellow sticky notes, and we put up on a great big whiteboard the different teams that we believe we need to have in order to be successful for our upcoming 12 or 18-month period. And we designate who the leader of those teams is, just because that's an important sort of management decision. And we decide how many people we need on those teams. But beyond that, we don't really say much more. And instead, we explain to all the members of our team what each of these teams is going to be doing for the next 12 to 18 months. And then say, take 3 sticky notes for each person with number 1, 2, and 3 on it, to designate your first, second, and third choice for which teams you'd like to be on. And then, it takes about a week to get everybody to put their stickies where they want. And you can imagine there's a little bit of like, hey, I want to be on your team, or I want to be on, like there's conversations that take place, which is great. And we wind up with a set of really suggestions or requests from people as to which team they want to be on. There isn't some laborious interview process or anything like that. It's just placing your sticky on the place that you'd like to work. Managers get together and try to resolve any sort of disputes or concerns, or make sure that the teams are about the right size and all that. Almost everybody gets their first choice. Nobody gets relegated to their third choice. So we're actually going to stop using the third sticky because we've been able to successfully put everybody at least on their second choice. And it's really enabled folks to feel like, okay, yeah, wow, I have some say as to where I go. I don't have to leave the team to make a choice about where I work. I can make that choice within our team. And I'd say about 80% of the people stay on the teams that they were previously on, which is great. You have some a real consistency across the sort of over time for those teams. But there's also some cross-pollination that happens as a result of people moving around. And so now we've got some more education, more empathy, more connections between our teams as a result. So that's how we changed our teams. I need to take a drink. Oh my goodness. Okay, so I need to talk a lot faster if I'm going to get done here in my allotted time. Let me talk about how we plan now moving forward. We have a series of aspects of our product that we plan. We have these sprints. Those last for 3 weeks. We have plans which last for about a quarter. We have seasons which last for 6 months, and then we have strategy which lasts for 12 to 18 months. Teams are responsible for the first aspects of those. So, what are they doing in the sprint? What are they doing for the next quarter? And where are they headed in the next season? Whereas the management team is really more responsible for sort of our strategy and what direction are we headed. And once again, here's the triangle of aligned autonomy. And we've really set that sort of split between alignment and autonomy right through the features. Like that's where the conversation really is in terms of prioritization and a lot of the conversations that we have at the leadership team level. We don't get involved at all in what stories or tasks, like we don't watch any of that. It's really, the conversation really is about features and strategy. And we just really let those details be managed by the engineers and the program managers on those teams. We've adopted this methodology that's talked about in another book that I'd recommend, which is called Measure What Matters by John Doerr. And it's called Objectives and Key Results, OKRs. And it's a really simple concept, but it's really been a powerful transformation for us because it's helped us really adopt a methodology that is focused on making changes that are measurable to customers, not just things that we do in the technology, but like we drive a conversation with ourselves about what is the actual impact of what it is that we're going to do on customers. And so it's an element of our planning process that's really helped us make focus not on activity, what are you going to do, but why? Like, what is the impact that you're going to have? And so we focus on these objectives and key results. And you'll see what we do is at the product level, we'll have a set of objectives and key results that are consistent for the entire team. And then we'll break those into a series of objectives and key results for each one of our services. And those services are, as I said before, the boards and the repos and the pipelines and those. And so every quarter, we'll set those objectives and key results in place. And we'll say, like we just finished the ones for this next quarter. And we'll say, for pipelines, we will have this number of users using this new feature by the end of the quarter. And now the team will work hard to make that true. And then at the end of the quarter, we'll step back and look to see how we did. Then those break into a series of team level OKRs, and then in some cases, individual contributors have their own OKRs that they're managing towards. But it's all aligned around the product ones that 3 weeks before the end of the quarter, we'll settle those, and then it takes another week to settle the ones that we have for the service. We'll roll those out, and then the team level ones will get set at the start of the quarter that's in question. I'm on a sprint here because I'm trying to get through 2 more in 8 minutes. We'll see how I can do. So we changed the way that we keep ourselves and our service healthy over time. What we used to do when we'd write a bunch of code and then we'd try to stabilize it is we'd have these periods where we'd really push towards something called code complete. And this might be a month or 2 worth of just hardcore coding for our environment. And what would happen is if you started to track the number of defects that were reported against that, it would be on the upswing as we were finishing coding because we're too busy writing the new features to fix any bugs. So we just let those sort of build up over time. And unfortunately, now it was time for us to start testing. And so the number of issues and defects would escalate. It would go even higher until sort of partway through that test and stabilization phase, because now we're totally focused on fixing a bunch of bugs. And it was like this sort of death march where we're like, okay, we're just going to fix a bunch of bugs until we get it down to 0. And so we'd do that, and we'd really push to get it down. And then we'd start coding again. And that process would cause another backlog of bugs. And so we were always on this roller coaster, never really sure if what we had was good. And it was really hard for us to have any predictability around when we were going to be done. So we've taken that, and we now insist that every milestone, every sprint is shippable. Teams check directly in domain through the process of pull requests. And we've now gotten to the point where we never have this sort of big sort of backlog of bugs. Instead, what we do is we follow something we call bug cap. And basically what we say is you take the number of people on your team, multiply it by 5, and if you ever, as a team, have more bugs than that, then you have to just stop. writing new features. You have to go and get that number down below. And so if you have 10 people on your team, you have a 50 bug cap. And if you're above that, you're in what we call bug jail. And when you're in bug jail, there's no new features. Instead, you're working to get out of jail. The other thing that we've done is change the way that we think about operating the service. I mentioned that each team is responsible for their code as it runs in production. Now, of course, there are times when there are regressions or live site incidents that impact those features. And of the 10 people on a team, at any one time, there's a primary and a secondary person who's responsible for responding to those issues as they come up in production, to start the investigation and to hopefully find a resolution to them. We don't just assign that to the 2 most junior guys or anything like that. Instead, it's a rotating responsibility. And we call those 2 people, the primary and the secondary, our shield team. And so that shield team doesn't have product feature responsibilities while they're on this duty. And instead, they're responsible for responding to live site incidents, as well as perhaps fixing any repair items that may have come up in the past. They're just looking after the health of the system. But that responsibility transfers from person to person to person throughout each week, so that everybody, including the lead, has this responsibility at some point through this cycle. And it's really helped first drive home this point of accountability. I'm responsible for the whole thing, so if I do something wrong, I'm likely to get a call in the middle of the night when something breaks. But also enables everybody else on the team to just really stay focused on working on their code so that they're not constantly getting interrupted. That's the responsibility of the shield team. All right, the last thing that we've done to really embrace this DevOps culture, and perhaps in a way, one of the most important because it really enables us to move more quickly, is we've evolved our code base to be in sync with our culture. Here's the problem that we had. So we have these 3-week sprints, and we'd start all of the teams, sort of together at the start of that 3-week sprint. They do a little bit of planning, and then they'd get to start writing some new features. And they'd start checking those new features in, but there are these dependencies that last sort of between them. And so there'd be a fair amount of coding and trying to figure out how things are going. And then towards the end, all of the teams would be sort of wrapping up their features and then trying to integrate them all in at the last minute. And so we found ourselves in a situation where there was a lot of integration debt at the end of those 3 weeks because there were all these features that sort of depended on one another, but were sort of being delivered together. And so because of this problem and because that wound up pushing a bunch of work into the next sprint, which was bad because we're supposed to be planning the next sprint at the start. We actually said, okay, wait a minute, no new features included in the code until after the 2nd week, and the 3rd week is all about integration. Well, that was a bummer because that's like 1/3 of our engineering time now dedicated to this sort of cross-team coordination in terms of putting those pieces together. And so we decided that was also a bad solution. So instead, we've introduced this notion of feature flags. The idea of a feature flag is we're going to keep the old code in place. We're going to keep the old functionality in place for as long as we need to. But in the case where, and this is a runtime decision, not a deployment time decision, in the case where there's some new feature and some new capability, it's off by default. But you can turn it on in, either for a particular test environment, you can turn it on for a particular customer, or in a particular scale unit. But there's a lot more control for our developers. And so what would happen is Team A would deliver some functionality that Team B was dependent on. Well, so Team A would put it into production, but behind a feature flag. So it's not running normally, but it could be turned on in one of the deployments in order to enable that sort of integration testing. So Team A gets their work done. Team B is ready to start testing that functionality, and they can, in a specific instance, go ahead and turn that flag on. Now the code path flows through the new code that allows them to test integration. But most of the accounts or most of the scale units that are out there, most of the customers are still running the old code. So it allowed us to have dual code paths in production to really help with this sort of integration testing. Once we got to the point where we had high confidence in that integration testing and all the pieces flowed through together, might be a sprint or two later, we were then able to turn the flag on for everybody, for all deployments, and then replace that code and get rid of the original code path. And so this sort of dual code path approach enabled us to have a much better integration of all of the pieces for our code, rather than really trying to coordinate across each of the teams around a deployment. Deployments are hard. It's a synchronization point that's really a challenge for us. And so we really tried to move that out of that realm and more into this sort of runtime dual code path realm instead. So this story that I've told you, you may be wondering, is this too good to be true? Is it all just rainbows and unicorns? And I'd say that, you know, you saw my example earlier of the number of features that have been deployed by our service over the last 6 years and the great increase there. So, you know, there's some evidence there. I'd say that it wasn't a crazy mess. Like, it wasn't one of these things where just like there were all sorts of mistakes along the way, but we did make mistakes. We did change and adjust along the way. And I think this is one of the key parts of our story, which is that we always had a sense of where we're trying to go. And in fact, we're still on this journey, but with key checkpoints along the way, and in our case, every 3 weeks, we're able to make adjustments and able to improve and learn from the way things are working for us. And so this has been an important part of our journey, is that learning, where we're able to have retrospectives as a team to figure out what works and what doesn't, and then to adjust along the way. But like I said, the journey doesn't end. We're still on this process. We still have challenges that we're adopting. We want to improve our velocity even further. We want to make deployments take less time. We want to be able to be more responsive to customers. We want to be more competitive. And we believe that by embracing many of the practices I've talked about and really having a more learning-oriented culture, we'll be able to make those improvements along the way. So we've gotten from A to B. We've still got C, D, and on throughout the rest of the alphabet for us to go through. So with that, I thank you very much, and dank je wel. And I hope that you have taken something from this talk that will help you and your teams through your transformation towards a DevOps-oriented culture. Thank you. Yeah, thank you.
Well, I don't know for you, but for me, this story wasn't about ups and downs. It was a straight line. It was good. Yeah, thank you. Thank you a lot. You had a good day, all? Yeah? I started with a question about how do we like the clinics? Some feedback? Anybody cares to make a remark? Yeah?
Short time, what you want to put in it's quite short. I was in the Maven room, and too much to do to fit into the 1 hour, 1.5 hours.
Yeah. Tastes like more though?
Yeah, it was fun to do.
Yeah, it was fun. Okay. Yeah, take it with us.
Short time.
Yeah. Other remarks?
Yeah, I got a question. I love the fact that developers become testers and testers become developers. But in real life, sorry, I want to answer you.
Okay, I'm ready. I think it's still on. Yep.
In real life, not every tester can be a programmer, right?
That's right. Yep.
So what do you do with the testers? Are you firing them?
You know, I think that in our case, certainly some people left the team. There's no question about it. I think it was more their choice. Like they saw the writing on the wall where they said, oh, I see how the expectations are changing and I don't feel like that's something I want to learn or I want to improve at. And so some left the team for sure, no question about it. Others looked at it like, hey, this is great opportunity for me to learn more. And they really dug in and we gave them the ability, like we didn't change it overnight and say, sorry, if you're not a good developer today, you're not going to be able to join our team or stay on our team. So there was a bit of transformation and change there, but for sure some people left the team. I don't think we actually fired anybody. Yeah, good question, thanks.
Thank you. Other questions?
The shuffling of the teams every 18 months is a very interesting idea, but
Yeah.
I'm wondering what does it mean for the velocity? What does it mean for the knowledge transfer? And what does it mean for the ownership of the features?
Yeah, that's a great question. I think that we are careful not to do it very often because it is disruptive. But first, like I said, about 80% of the people stay around. So from a knowledge transfer perspective, it's not a particularly big challenge. Second is if somebody was unhappy and wanted to move to a different team and we didn't have this process, they would just leave our team. So we found this to be more healthy because they're still around and we can take advantage of their expertise. In terms of ownership of features, that's relatively stable within our organization. There are times when we move one thing to another team or whatever for load balancing purposes. But there is a sort of an ongoing, enduring identity for these teams that that ownership stays pretty consistent. So we haven't really seen that to be a problem. Thank you.
Yeah, so a lot of change has happened. What was the biggest challenge that you had or the organization had and why?
Let's see. I think that probably one of the biggest challenges for us has to do with just the notion of scale, both in terms of number of people and time. Like we said, hey, we want to be a more agile team. And we all sort of had a view of what that would mean. And we thought, oh, just overnight, we would be able to sort of embrace that. It took us 6 months to really have what we considered a well-oiled sort of approach. And so having the patience to allow for that to take place, I think was one of our biggest challenges, just because of how long some of these transformations take. We're in the midst of going through another transformation right now as it relates actually to the OKRs. And I just constantly have to remind our team, this is a marathon, not a sprint. And it's going to take us several months for us to get through this. And we just have to have that patience. Yeah.
This is regarding the vertical slices that you did from the horizontal.
Yep.
So there are some horizontals that could be of little use within the sprint.
Sure.
So if you're going to split up vertically, then you either need a lot of people with the expertise, for example, AMQ layer or database layer.
Yep.
Once you create one table or for the sprint, it's over.
Yeah.
So how do you split? And if there is any technical issue, you really need a real good in that area.
Sure.
I agree everybody can learn a little bit for their own sprint, but
yeah,
how do you manage that?
Yeah, so first and foremost, I think we'd say that it's, we expect our engineers to have some breadth. Like there is an area that I'm really good at, but we're expected you to also be able to do UI or also to be able to do APIs. And that allows us to have more load balancing when there's not as much database work to do, for instance. To your second part of your question around, hey, if you really need a deep expert, there are deep experts in other parts of the team. It's not like they're completely on an island all by themselves. They can call in somebody else for their advice and suggestions, and perhaps even to help write some of the code, or perhaps to do a code review through the pull request or whatever. Like there are a bunch of different ways to get involved and to pull in that resource. And so we see a lot of crosstalk between the teams in that way. And actually, the the yellow sticky exercise that we have enables that even more because people know each other better because they've been on teams together. So that's what we've seen so far.
Yeah.
I have a small question with that dual code path.
Yeah.
I mean, I will take a hypothetical example like team A, team B, both are working on the same kind of code, and team B has a dependency on team A code, and team B completed their testing and everything, whatever they built, but team A is not able to complete in the sprint in the timeline. So will you hold the deployment of team B as well, or will you push to?
No, team B will deploy, but behind a feature flag. So that their code is in production, like they don't require another deployment to get that out there so that somebody could test it, but it'll be turned off via the feature flag. When team A catches up and gets their work done, then they can test in production against that particular code path, but not impacting a bunch of customers because customers are still flowing through the old path.
But still, because of the dependency, the code may not work in the production. So how will you handle that situation?
Yeah, so I think just in general, our approach is that you don't deploy something to production that has a dependency that's not already there. And so, unless it's behind a feature flag. And so that way, we don't have these sorts of race conditions that prevent you from, from one of the teams moving forward. Of course, the capability, the new customer feature or value isn't available until you get both of them there. But at least it's not, sort of running in production and not, not able to function at all because it's not, because that second dependency isn't there.
Will you be there for during drinks?
Well, sadly, my workday starts in 15 minutes. So I've got to get back. We've got phone calls and all sorts of meetings and stuff. So I unfortunately won't.
Yeah,
but
that's a pity.
Yeah, I'm sorry about that.
So no questions. If during drinks, if somebody has questions, can they reach you?
Absolutely. Yeah. So my email address is jeffbe@microsoft.com.
Yeah, and you're kind of active on Twitter.
And I'm on, @JeffBE on Twitter as well.
So it's not that difficult, but
yeah.
So if you have any questions,
come see me, please.
Yeah, okay.
Yeah. Thank you.
I think enough for now. Yeah, I hope you had a good day. You will get an email through which we ask you to fill in an evaluation so we can learn and improve for the next time. If there aren't any things you want to talk about, we're still here with the orange shirts, so please talk to us. And be aware, this was a joint effort with one of the many communities we have. There's help me please. We have a quality community at this moment, who was involved in the demo today about the, I want to say, unbreakable pipeline, which is kind of neat because within a month it was there. We have a Java community which was involved in the organization of this event as well. So if you have any ideas, if you care to join, Chris Stopper, there, one of the great promoters of the many communities we have, feel free to join him, talk to him. Yeah. If you have an idea and you think there's no initiative around it and you want to build a group of interested people around it, well, join him. Yeah, hand over your ideas. He can help you and give you pointers in the organization through which you can get organized. Yeah. Yeah. Yeah, the automation community. Yeah. You'll be here during drinks as well, right? So, talk to them. then the only thing left to do is thank all the volunteers that have been entertaining you guys. So please step forward. Dennis Mes, Sjoerd Giesbers, Jan Mulkens, Arno Kuller, Harm Kolenbrander, Ralf van Beek, Adriaan Thomas, Leon de Bruisenaren, de La Woestijnen enzovoorts, et cetera, et cetera. En Sophie. Ja, ik zag al dat jullie met z'n tweeën bij de workshop stonden. Ja. Thank you very much. Mag je wel eens eerst? Ja? Dank je wel. Dat was ook niet grappig. Dankjewel. Ja, dankjewel. Ja. Oh, dank je. Ja, ja. Ja? Yeah. Oh, is Jeff already gone? Then you'll need to drink his beer. Ja. Dat is Chris. Ja? Dank jullie. En veel plezier tot de volgende keer. Heel goed. Ja. Ja. Goede opkomst. Ja, goede opkomst.